in PowerPoint?
You show, right under slideshow.
Slideshow?
You show, the first one.
But with presenter tools, do you know where that is?
Oh. Like for markers?
That's okay. I'll be all right. It's just a little easier to navigate. All right. So, good morning, guys. My name is Katrina Housel, and I've been working in the Human Language Processing Lab for past year in summer. And I have an excellent advisor who's been letting me do research in phonological priming and spontaneous speech production. So, our first question is, why do we study language production? We go around speaking and talking to each other all day, but what's so great about it? There's a couple of really cool things about language. It's really fast. We speak at about 150 to 180 words per minute, which if you divide that out, we're talking at 3 words per second. It's also rather effortless. We don't wake up in the mornings thinking about how terrible it's going to be to try and convince or to try and talk to our friends and family and coworkers about the things we need to. It's also robust. And by robust, I mean that language, when we speak, is generally fluent. We are very well practiced in our native language, and we can convey our ideas very effectively to other people. And we aren't tripping over our words and taking a really long time to come up with a message and a sentence to talk about. And the last really cool thing about language production is that we plan and speak at the same time. So there's a lot of evidence for this, that as we're saying the very first part of our sentence, we're already planning the next things that we're going to say. So we don't just stop and think about a sentence and then go for the whole thing. We're actually starting to produce our sentence as we're coming up with more to talk about in the sentence. So, in sentence production, we've got our message. And our message is what we're trying to convey. And we need to get it all the way down to articulation so that we're talking to our friends and family. And there's a couple of components that go into this. First, we have our syntactic structure. And a syntactic structure is basically the grammar of the sentence. So this is actually oftentimes evidenced. We see people typically, when they make a mistake in a sentence, they switch nouns for nouns and verbs for verbs, which is very interesting. So we have a sentence that a sentence structure, and then we can fill in the blanks for the different words. We also have selecting which words to fill into those blanks. So that's word selection. And the interesting part of how language interacts is that no one knows exactly quite which order everything is going in. Some things might be happening first, and some things might be happening at the same time. And so my experiment today is going to be looking at phonological information, which is the sound information, and how that affects word selection, and then into the grammatical structure that we choose. So we're not exactly sure how everything interacts, but this was hoping to clarify some of that. So in word selection, we have 2 types of information. The first kind is semantic information, and this is the word meaning. You're not just going to spit out a random word that doesn't have a real message to it. We also have our phonological information, and these are the sounds in the word, and also the order the sounds go in order to make up that word. So, for example, if we had a sentence like, Hannah gave the game to the boy, we could either pick each step in order. And so we might say, all right, I want to say a noun, a verb, and a noun being given to something else. And then, after we've thought of that, we can pick the nouns, and then finally pick the words, and finally pick the sounds, and then start talking. But this would take forever, and we talk at about 3 words per second. So there's also the second possibility, which is that we pick a syntactic structure, and then we pick nouns and verbs to fill in the slots, and we pick the sounds and place them in order. And these are all happening like in similar times. So today we look at how phonological encoding interacts with other parts of sentence planning, and then how that affects syntactic structure. So as the phonology of the intended word is retrieved, activation spreads to similar sounding words. For example, if you see a cute little cat, you're just going to start retrieving the sounds k, a, and t in that order. And this will also activate words such as cap, can, that, and fat. So from current experiments, we know a lot of stuff about phonologically similar objects. In experiments, we oftentimes see, okay, actually this is a very specific kind of experiment that people have done. And they've taken a picture like a cat and a can, and these are very phonologically similar. And then we manipulate how long, the amount of time it takes between showing the picture of the cat and showing the picture of the can. So if we show the cat and then have a black screen for 300 milliseconds and then show the can, we get facilitation of naming the second object, which means that we are faster at naming the second object. If we show the cat and then wait longer than 300 milliseconds to show the can, we get inhibition of naming the second object. So it takes people more time to say that second object. Also, if the cat and the can are shown at the same time, it'll slow down the naming of the can. So, previous results were mostly found by forcing people to produce words in isolation. But that's not what we do when we talk. I'm not just sitting around pointing to the chair and saying, chair, and screen. We would be very, very weird people if we did that. So during real language production, how does the phonological similarity affect what we say and how we say it? Is sounding similar good and easy, or is it bad? So in my experiment, participants described short animations. These animations involve scenes that are compatible with several verbs. So if you see up there, there's a woman handing a teapot to a boy. And this could be described in a couple of different ways. It could be a hand. She hands the teapot to the boy, a pass, or a give. So in these giving events, there's 3 things that we can manipulate. We have the giver, which is the person who gives the object to the recipient. The object is the thing being given, and the recipient is whoever gets it. So my experiment manipulates the giver's names. We had Gabe, Hannah, and Patty. And these were similar to one of the verbs compatible with the scene. Gave, handed, or passed. So the question was, do the giver's names facilitate or inhibit the similar sounding verb? So would Patty pass, hand, or give a book to the woman? So this is my cast of characters. We had Patty, Gabe, Simon, and Hannah. And Simon was included because we had filler trials, so that not every trial that participants got to see was a hand or a give action. Otherwise, we might see something called priming, where people just use the same word over and over because it works. And people like to use what works. Okay, hold on a second. I feel like a little frozen here. Okay. All right, so here's an example of a video that a participant will get to see. in this video, the man Gabe would have been handing a teapot to the boy.
Try displaying it in the slide view instead of in the slideshow.
A slide view. Oh, wait. That worked. Okay. So there's one. Here's another. This would be with Hannah. And this would be with Patty. So the same objects were handed past or Gabe by Hannah, Patty, and Gabe. So say that this wonderful woman was our participant in the experiment. She might be thinking to herself, should I call this action Gabe or handed? Now, this isn't actually a conscious process. It's all subconscious. But from the name Gabe, if that's what the trial she just saw, activation would spread to words like Gabe and gang because they sound similar. Gabe is more active, so the prediction would be that she would say Gabe to label the handing action. So in my preliminary results, the highest bar in each row is for the phonological match. So basically, for these Gabe trials, Gabe is our red, Hannah was our orange, and Patty was our light beige here. So for Gabe, Gabe was our highest. If the person saw Gabe, they'd be most likely to say Gabe. If the person saw Hannah, they'd be most likely to say Han. And if the person saw Patty, they'd be most likely to say Pat. Now, Gabe, we knew going into this that Gabe was going to have a huge bias because it's the most typical way to describe a giving or handing action. So what's really cool about this is when people choose the less frequent verb, they typically choose it because of the person who was doing the action. So this is really cool. This is definitely an example of phonological priming. Oops. Okay. So we found phonological facilitation in spontaneous speech rather than an isolated production. And this means that from our box called phonological information, it has an effect on which words we select. And this is already a really cool contribution to psycholinguistics because this is the first time we've ever seen phonological priming in a sentence elicitation task. And also, most experiments look at phonological choices of the noun, but this one looks at verb choice because we have this really cool animating software so we can look at the verbs. So now, how does this affect our syntactic structure? We've just found phonological facilitation. So we have these two words that sound really similar, and we have a couple of ways we can arrange our sentence to see how close and be from one another. So verbs like give, hand, and pass are something called ditransitive, and this means that they can take two forms. We can either say the object first, so this would be a sentence like Gabe gave the book to the woman. We can also put the recipient first and say Gabe gave the woman the book. So now that we've found facilitation at the word level, will that make things harder at the sentence level? We also included trials to the verb. So this would be a trial like gate. So Gabe gave a gate to a woman. Our questions were, will the participants be just as fluent? And will the participants use a structure strategically to put more space between the phonologically similar words? There's a couple things we might expect. We know that tongue twisters trip people up. Otherwise, they wouldn't be tongue twisters. And other experiments in psycholinguistics have shown that people try to put more space between similar sounding words. But we've just seen phonological priming. So perhaps the similar sounding words will be more readily available in our brains so that they'll be more active and easier to produce. So for an example of this is a gate, and all our participants got trained on the objects and the people's names. So that's a gate, which is going to work now. So our predictions from previous psycholinguistics experiments would be that people would reduce phonological similarity. So our participant here wants to say Gabe, gate, and we want to put a lot of space in between our phonologically similar words. So she'll talk about the recipient first to avoid repeating the same phoneme, which is the sound. So Gabe gave the woman the gate. So that's what we predicted, but the exact opposite happened. Participants said the object first, more often than for the phonologically similar verb and object. So they would say, Patty passed the pan to the woman. This means that people put less space between similar sounding words. However, in our sentences with the phonological matches, it tripped people up. This is a graph where we're looking at the number of disfluencies per sentence. And as you can see, whenever the red means that there was some sort of phonological similarity in the sentence, and the orange means there was not. And as you can see, whenever there was a phonological similarity in the sentence, it was way more likely to have a disfluency. And a disfluency might be like, just a pause, a restart in the sentence. So we definitely saw that it made it a lot harder to create the R sentence well. So in conclusion, in relatively spontaneously produced sentences, saying one word seems to make it more likely to use similar sounding words in the remainder of the sentence. But this very fact seems to be somewhat disruptive for production. So in the future, we're still collecting data from more participants, and I'd like to start looking at the amount of time people put between phonologically similar words. They might just be taking more time and slowing it down to say the words close together. I'd also like to start looking more if there is a relationship between the objects and the verbs. So will the object pan make the verb pass more likely, just like Patty will? I'd like to give a special thanks to Daniel Friel, sitting right over there, and Irene Minkina for coding my data, and also a heartfelt thanks to Andrew Watts and Dr. Yeager for helping me write the experiment and for all their support. Thank you. Does anyone have questions? Okay.
I have a thought that I want to pass by, but perhaps people slow down when the words are similar because of the actual production of words like past, pan, patty. You're going to have to rearrange your mouth in subtly different ways to do it, so it gets more into the linguistic aspect of the formation of the words and how we're saying them in our heads before.
Yep.
Thank you very much.
Thank you.